Good morning, everyone. I hope you're having, or good night. I hope you're having a wonderful day, or have had a wonderful day. This is one of my returning episodes back to YouTube. So I've taken quite a good break, well-needed break from content creation, and I've scheduled out how I plan to make things work moving forward. Today, we will be solving leetcode question number 217 contains duplicate. So for the audience, just for some context, I'm following by Neetcode 150, and I intend to make some content in the name of, I guess, developing, somewhere, I guess just developing videos for the solutions. Now, you can see probably like a nice little logo at the top that's base script. So a project me and my friend Mahir worked on is like a cool little database that we thought making, as we learn our languages, making it for would be like a database for learning languages. And so it's open source and anyone can contribute to it. Now, to start with this question, let's read through it. So we're given an integer array, nums, and we would like to return true if any value appears twice in it, in the array, and false if every element is distinct. Okay. So we have a few options. Just given, we can run through the test cases, but we have a few options. So essentially, to explain this first test case, it's apparent that we have one and the other one, and so like we have one appearing twice in the array, so it'll output true. And then here, there are no duplicate integers, so we'll output false. And once again, we have three ones, and multiple other integers repeating, and so it'll output true. So the way that I solve this, and I'll start off. Maybe I'll start off with least optimal solutions and then move forward. So the first way we can go about solving this, and I hope my handwriting is good. So we could brute force our way into this. Maybe I'll try a different pen color. All right, let's hope this one's better. So we could brute force it, and we could brute force it with the double for loop approach. Now, if we traverse over, and if I write it out in a larger font, if we traverse over this array twice, what we can do is check, and when I say double for loop, we can check basically the first point. We can check the first index in the first for loop, and then in the second for loop start the for loop at the second index, and basically continue to traverse it in the sense that this stays at 1, then this pointer, maybe let me get rid of that. This pointer that was at 2 is going to go to 3, and then it'll go to 1, and then we'll move. Let me get rid of this. We would basically move the first pointer to the second one now and continue over this. Now, this solution will work because you'll be iterating over the entire index basically twice. Essentially, you're finding all the possible permutations, and what this will end with is a time complexity. Maybe I'll just put time for the sake of it. Time complexity of O of n squared, because you are going over whatever length of the array squared. So if this was, for example, an array of like 10, then your time complexity, because you're essentially looping over it twice, you'd be looping over 100 entries. And then you'd have a space complexity of just O of 1. And it's O of 1, from what I understand, because you're not taking up extra memory to process the, like a bulk of your program is running over the size of the index, so that's how much time it'll take. Space complexity, you don't make any other, you don't make another array, for example, to loop over this. So you're just using the array given. So it's O of 1, it's whatever the size of the original array was. Now we could move on, with that being said, to, and I gotta maybe traverse my notepad a little bit easier. So this is a brute force approach. And now let's cover a second approach, which would be called, so we can sort the array. Now, for example, we take the same first case, and then we run this through our sorting algorithm, and we get now 1, 1, 2, 3. Now, the nice part about sorting it is now your elements, get a different color for this. Sure, actually, there we go. So now the part that's nice about this is that all the same elements are adjacent to one another. And this can increase, this will increase the time complexity of our sorting algorithm, or sorry, the time complexity of our program, because now if we sort through it, so we have like a nums.sort, for example. We'll be solving this in Python. I forgot to mention that. Now what you can do is you can start off at this index value, just to get rid of. This is something that I learned, that if you usually start off at like your, or set your comparisons to start at this index value and compare to the prior, you reduce the risk of running into an index out of bounds error. Now, so the great part about this is that since all your elements that are similar are adjacent, you can just traverse through it from the second index and compare to the first. And you can do this across the board. So even if I gave a different example, something along the lines of like 1, 2, 2, 3, 3, for example. Now, yeah, like we said, since, like, for example, it won't catch it on the first one because these are two distinct elements, but as soon as it goes on to the next index array with a single for loop and iterating through this one time, we're then going to draw a comparison to the to the index array prior to that, and determine that, oh yeah, this is a duplicate, and return true. Okay, so that's the sorting way of going about things. Now, the one that I used, the one solution that I used, and eventually got to, like I've done this question a few times now. So there's a data structure called a set, okay? And the way to, maybe it'll be best to do it like this. So you can define a structure called a set, okay? Now, a good way to think about this set, and anyone feel free to correct me if I'm wrong, is that essentially whatever goes inside this set is unique. And you can't necessarily operate on a set the same way you would an array, but it's neat to think about it as an array. Maybe let me draw this better. There we go. So it's neat to think about it as an array because maybe I should put, I'm going to change this as a dynamic pen because I realize I like it more. So if I put something in there, whatever it may be, let's call it A. And let's just say I throw in a few more objects called B, C, and C. And let's just say this was an array. Okay. And I want to like add it to my set. I'm going to reduce this by a lot. Sure. Okay. So what the set ends up producing, kind of as a function, you could say, is like, okay, you threw in A. I'm going to add that to my set. A is cool. B is cool. I don't have another B. Now when I get to C, adding the first C is fine. It doesn't pre-exist. Adding the second C, it'll be like, whoa, I already have a C here. There's no need to add another C. And so by definition, a set only really contains unique and distinct values. And that's really helpful in this case because what you can do is if you define a set, you can iterate through your nums array and essentially just use like the in operator. And so if A is in my set, then return true. And if it's not, then just add it. And, you know, after we've gone through the entirety of the nums array, used alphabets, sorry, but after it's gone through the nums of the, gone through all the indexes of the nums array, if I didn't return true, then just return false. And so that's the, that solution has a time complexity of O of n, because we only have to iterate through the first array once. And I really hope this works with me here. And a space complexity also of O of n, because we create our set, and our set is of the same size as of our original array. Now, one thing I forgot to mention, which I believe I should, is the time and space complexity. Oh, whoopsie. Hold on, let me get rid of this really quick. So yeah, the time and space complexity of our sorting algorithm. So if we sort it, we actually get a better time complexity. On log n, because, and from what I understand, the log n for me is a little bit ambiguous, I won't lie, but I believe that when you iterate through your array, once you've sorted it, you don't have to sort through the entirety of the array if you catch a duplicate. So to just reinstate this, okay, this is my drawing pad's a little bit hard to work with sometimes. So for example, we have like 1, 1, 2, 3. I can stop my traversal right here at the second index. So it's not O of n because I have to go through all of it. And it's also O of 1 memory because I don't make anything new. And I would say that because, you know, you have O of log n time complexity and of space complexity O of 1, it's just about the same as your O of n set. But I think that I think that for optimal solutions, something like this is more preferable. Although O of log n is faster, you kind of give up time complexity for, and this could be O of n either, depending on how your sorting algorithm works. But yeah, if you sacrifice some time complexity, you get O of n. And I think O of log n is faster, but I'm not quite sure. Maybe someone could correct me on that. So now what we could do is we could get into our optimal solution. So just doing something really quick. Okay. Now, I think it's fine, even if it's cut off. What I'll do here is I'll just actually define it like that. So we can start off with, oh, I just realized. Okay, hold on. Hold on, guys. I'm going to try something. Okay. So I want it. All right. I'm doing something crazy. Hold on. Maybe what I'll do is this. So I got to delete it backwards. Oh, this is kind of trippy. And then the for loop, and then the if statements. All right, sure. Okay, I think that should work. So, the first thing that we're gonna do is define our set. What we can then do is define our for loop. So we defined our set as the structure that we want to use to add our index values of nums into. Our for loop will then iterate through the length of nums. Because they're the same length, then this is perfectly fine. This return false makes sense now. And so the logic of it is, if my current index value is not in the unique set, then what we're going to do is we're going to add the current index value to this set. And if this is not true, it means that the current value is in the set. And so then we're going to return true, because that's what we want to do. If the current value of nums is in the set, that means it's a duplicate. And if it's not, then we just continue to move on to the next index value. And after we're done, if we found no duplicates, i.e. return true, we're going to return false. And that is leetcode question duplicate integer /217. Thank you all for listening, and I should probably be more enthusiastic in the next one. So bye-bye.